So good afternoon everyone. Hereby, let's begin the fifth day of workshop conducted by the Department of Civil Engineering, Association with VVIT ICI chapter. May I grab this opportunity to welcome our speaker of today's session, Dr. B.S. Dhanya Vinod, who completed her PhD programs from IIT Madras. She is presently working as an associate professor at Rajiv Gandhi Institute of Technology and DEC Kottayam. Her area of interest include the durability of concrete structure, corrosion of rebar in reinforced concrete, and structural design of reinforced concrete structures. She is also the recipient of ICI Ultratech Award for Outstanding Young Concrete Engineer 2018. ICI National Award for Best PhD Thesis in Concrete 2016 and Best Paper of Poster Presentation Coron 2016 and so on. Welcome you ma'am, and I sincerely welcome each and every participants and the faculty members who joined us with this session. Let me also thank the crew members of VVIT ICI chapter for this event. Thank you. So may I now pass the session to our speaker, Dr. B.S. Dhanya Vinod.
Hello. Hello, am I audible?
Yes, ma'am, it's audible.
Yeah, I think the screen is not coming. Whether the video is visible, I'm not able to see anything.
Yes, ma'am, the screen is there, ma'am. Video and screen
Video
is
is
there.
coming?
Yes, ma'am.
Okay, I'm not able to see that. Okay. Thank you, Divya, for inviting me to this platform for giving a webinar on durability of concrete. And I thank the organizers, the students, and the ICI members, and the entire team of VVIT for inviting me to this platform. And so today's session is on durability-based design of concrete. So as she had mentioned, I'm an associate professor in civil engineering at RIT, Government Engineering College, Kottayam, and I've done my research in the area of concrete durability in IIT Madras under the guidance of Professor Manu Santana. So let us move on to today's presentation. So before I start, I just want to introduce you the designed concept of concrete durability. So why do you think that durability based design is necessary? Or rather, the question is, how do we design concrete these days? So normally we do the design for concrete based on IS 10262 2019 version, the latest one, where the strength is the only concern. And we have glimpses of durability based provisions in IS 456, the code of practice for the design of reinforced concrete, but it's not sufficient. Why we need to think about durability as a major concern? So that is what I'll be covering in the introduction section, and then we'll discuss about the deterioration mechanisms of concrete, followed by the challenges that we are facing now on the durability based design of concrete and the challenges which are specific to India. So I think, can everybody mute your mic?
I have muted, ma'am. I have muted everyone. You can unmute and speak, ma'am.
Okay, fine. Thank you. So this is why we need to have a durability based design. Why? Because it is a time when we are building our nation for the second time. A lot of highway projects, bridge projects, seaport, airport, river interlinking, housing, utility systems, all these infrastructure development is happening these days. And we are investing a lot of money for the construction of these mega projects. So, and when we think about an infrastructure project, the major construction material is none other than reinforced concrete. And reinforced concrete has its own advantages, like it can be made from locally available materials. You have studied all these in your BTech classes. A lot of advantages compared to the steel structures, and that is why concrete is the most sought after construction material just below water. And we are spending a lot of money for this infrastructure project, and also because many of our infrastructure and also the residential projects, everything is getting deteriorated within the service life itself. We have to spend a lot of money for the maintenance and repair of these projects. So we have a huge task of maintaining the aging infrastructure and constructing new durable infrastructure systems. And this is also very important. The cost of corrosion is significant. Why this is highlighted? Because most of the reinforced concrete deterioration is happening because of the corrosion of the steel rebar, which you might have observed in your institute, in your surroundings, in your home itself, a lot of signs of premature corrosion of steel in the rebar. And this is an estimate. In 2012, the direct cost of corrosion was around 2 lakh crores per year. It's an old estimate. And corrosion protection strategy to minimize the repair and maintenance cost is a must for us. And what is the traditional definition of concrete durability? So that means we have to make our structures, especially the reinforced concrete structures, durable. So then what exactly is meant by durability? Durability is nothing but the resistance against deterioration. And the ACI code defines durability as you can see in the screen. Durability of Portland cement concrete is defined as its ability to resist weathering action, chemical attack, abrasion, or any other process of deterioration. So that means the durable concrete will retain its original form, quality, and serviceability when exposed to its environment. When we think about concrete durability, the concrete durability issues can happen either from the concrete system or from the aggressiveness of the environment. The concrete system involves the materials that we have used for the construction, for example, the binder, like for the PPC or PSC or ordinary Portland cement, or I'm going a combination of OPSC and any supplementary cementitious materials like slag, fly ash, silica foam, etc. How much is the content? What are the mixed design parameters that we have adopted? The type of aggregate, the quantity of aggregate, the admixtures, its quantity. So everything coming under the material section. And not only that. Hello? Hello? Hello?
No, ma'am, it's
Hello?
okay, ma'am. Someone else has
Okay.
spoken. It's okay.
Okay, okay. I thought you have spoken some issue with the connection. Okay.
No,
So
that's
then
okay.
we'll have the process. The process involves mixing, transporting, compaction. So whatever the processes involved in the manufacturing of concrete determines the process part. So the concrete system involves material section and processes. And the second part is the aggressiveness of the environment. That means where your structure is going to get installed, what is the kind of exposure that structure will have, or what is the type of deterioration that can happen in that particular environment. For example, if you have installed or if you use the concrete for a pavement, their abrasion might be an issue, shrinkage might be an issue. If the same concrete, same kind of concrete is used for the construction of a dam, there, in addition to abrasion, you might have cavitation, and all. And that case, we are not using a reinforcement, right? So in that case, we don't have to bother about the chloride-induced corrosion or carbonation-induced corrosion of the rebar. And if it is laid in a sulfate-laden environment, in a soil which is rich in sulfate, you might face sulfate attack. So depending upon the type of exposure or the aggressiveness of the environment, your deterioration mechanism may change. And the first part, we can do a lot of things, whereas in the second part, the aggressiveness of the environment, we will not be able to do much because it is the actual type of deterioration coming from its service environment. But we can design the concrete materials and we can modify the process so that we can get a good concrete system which will be durable, in fact. And there lies the importance of the specification. Like, how do we specify the concrete? And if you remember your concrete technology classes, how did you do the design of concrete? You might have designed it for M25 grade or M30, like that. So what does that 25 indicate? It is nothing other than the strength. And normally we don't have much other things, but some inherent or some deemed to satisfy approach is there, or some tables we have to satisfy based on the IS 456, like these minimum cement content, minimum or maximum wall cement ratio. So like that, some conditions are there which are indirectly pointing towards the durability, but our major concern is still the compressive strength, and we are not doing any other test other than compressive strength to check whether the concrete is okay. And by doing this, we assume that the durability and other engineering properties are a function of compressive strength. And this is not correct, which is being proved by the research which got happened long back. So still we are following this myth that durability is a function of compressive strength, or rather we do the approach that if your concrete is placed in an aggressive environment, increase the grade of the concrete. That will take care of the durability part. And this is not correct. And see why the durability is happening. I have divided this. Many of you have might have attended some of my webinars, and this is a slide which I and my professors are showing many times, because this is a crux where we call the inner chunk of concrete as the heart of the concrete or the heartcrete, and The outer zone concrete is defined as the or designated as the covercrete or the cover zone concrete. The inner chunk or the hardcrete is responsible for the strength, whereas the durability is obtained from the cover zone concrete. And there the key factor is the impermeable pore structure that we obtain in the cover zone concrete. So that means in order to get a key pore structure, it's not only the material that matters, it is the construction processes as well. If your cover block is not properly placed, you will end up with less cover. If your concrete is not cured properly, what will happen? If the curing is not perfect, your pore or the development of the porosity will be much more in that. So all these can lead to durability issues. So the key point to be stressed here is the strength. Strength is obtained from the inner part of concrete, and the durability can be obtained from the properties of the cover zone concrete. So in order to have a good durable concrete, we should have impermeable pore structure obtained at the cover zone concrete. And now coming to the different approaches of durability design, we have mainly two approaches: prescriptive approach and performance approach. In the prescriptive approach, that itself can be divided into two. One is called the avoidance of deterioration approach. For example, you are using a coating for the steel reinforcement. So what we'll do is we will avoid the contact of the aggressive species with the steel. If you're using stainless steel, so in that case also we are avoiding the type of deterioration. But that method is very costly, and for normal construction application, it's not economical. So that is why the another approach, which is called the deemed to satisfy approach, is evolved. And what is that? In the deemed to satisfy approach, we will put prescriptive requirements on the materials. Prescription means, okay, I'm specifying this value. If I use a particular content of cement, say 360 kg per meter cube, and if the water cement ratio is more than say 0.45, my concrete is deemed to be durable in that particular service environment. This is what we do right now. I'll show you some table 5, I guess, of IS 456, where we have these prescriptive requirements of the materials specified. And by doing this, or by satisfying these limits, it is assumed or it is deemed that this concrete is assumed to be durable in that particular service environment, which in many cases are not true. So that is why from the prescriptive approach evolved another approach called the performance approach, in which we specify performance-based tests and indicators. So here the performance is specified. Performance means what you need at the end in your structure. What is the parameter or the property of the concrete which is required in the structure? Is it crack resistance? Is it compressive strength alone? Is it shrinkage resistance? Is it chloride ion resistance? So whatever it is, that property will be specified. There should be test methods available to test these properties at structure, in fact, and based on these tests, and a lot of things are there, like the pre-qualification things and all. So we are not doing the design of concrete not only for the strength, but also for certain durability parameters, which are indicative of the performance of the concrete when it is exposed to its actual exposure condition or its actual service environment. And based on that, the quality rankings are given. So that is the first approach. And then came a more rigorous approach where the time is also coming. That means if I get a durability parameter of X1, my service life will be, or the service life of that particular structure will be, say 25 years. If it is X2, it can be 30 years. If it is X3, it can be 35 years. So like that, we will have actually a quantification of the service life of the structure. And this is very rigorous, and this need a lot of data, and these service life prediction models are to be developed for that. It is there elsewhere in the world, but in India it's still in the primitive stage. It's not that the engineers are not capable of doing that, but these things are to be validated with the real field data. So that is what is missing in our thing. So we are in the stage of moving from the first stage of the performance approach to the second rigorous method. So what I have shown here is that even though the IS 456 is in the deemed to satisfy approach, in all over the world, this is the approach has moved to the performance approach, and slowly we are moving from the deemed to satisfy approach to the performance based tests and indicators. So this is what exactly is the performance specification. It gives instructions that outline the functional requirement of the hardened concrete depending upon its application. So if the same grade of concrete, same M45 grade of concrete is going to the interior column of a building, its performance can be a strength and weight alone. Whereas the same concrete, if goes to the construction of a bridge deck, there it's not only the compressive strength matters, but the chloride resistance or the carbon dioxide penetration resistance. So all these matters. So it again depends upon its final application. The end that matters. That is the crux of the performance-based specification. Now, once we think about the performance-based design or the durability-based design of concrete, it's not only the strength that matters, it's the durability also matters. So these are the challenges that we have to overcome. First, we should have a clear understanding of the deterioration mechanisms. So I have listed out 5 points. And now we are going to see in detail these 5 points. So that is the agenda of today. So first one is understanding the deterioration and transport mechanisms of the for the various exposure conditions. So can any of the BTech students unmute and tell what is this mechanism? What is displayed on the screen? It's a durability issue of concrete, or rather reinforced concrete. Can anybody tell what is this? Can anybody tell what is displayed on the screen?
Corrosion, ma'am.
Yeah, it's none other than corrosion. Now, because of the corrosion, the covers on concrete has spoiled off. So we have different stages of corrosion. You can see some white patches, then brown patches coming out of that, and then some hairline cracks, then the spalling of concrete. So different stages of corrosion are there. So good that it is the corrosion of the steel rebar. Now, why corrosion is happening? It's, you know that corrosion is an electrochemical reaction, and for an electrochemical reaction to happen, you know that there are 4 essential parts required. One is the anode, second is the cathode, and then you need an electronic conductor, and you also need an ionic conductor. In a reinforced concrete system, the anode, cathode, and the electronic conductor is the steel rebar or the metal itself, whereas the ionic conductor is the pore water or the water present inside the pores of the concrete. You know that the concrete is not a perfect solid. The HCP or the hydrated cement paste is having a load of pores like capillary pores, gel pores, etc. And these pores is having water, which we already have given for the mixing. All water might not have used, and that water is not pure water. It is having a lot of ions in that. We call that as pore solution, and that pore solution is the ionic conductor. And in the corrosion, we'll have the anodic reaction happening. At anode, the oxidation happens. Ion get converted into Fe2+, and in the cathode, the reduction reaction happens and the OH minus ions are released. And why steel corrosion causes cracking of concrete? It's clearly written here. When iron gets converted into its oxide form, different types of oxides are formed. You can see here. Because of this one, what happens is that volume increases. And once the volume increases, it exerts pressure onto the surface concrete. And when this exceeds, when the pressure exceeds the tensile capacity of concrete, it will crack. So that is what is happening in the corrosion. So my professor always says that when you take 1 cup of steel, you will get approximately 6 cups of the corrosion product or the iron oxide. This is the major reason, or this is the reason, because of that you see the spalling of this concrete, because it does not have much space to sit. It gives pressure or it exerts pressure on the covers on concrete and it gets spalled off. And there are 2 major types of corrosion in reinforced concrete structures. One is called the carbonation induced corrosion, and the second one is called the chloride induced corrosion. So what is that? When we place a rebar in a highly alkaline system like the cement matrix, it will form a passive film around that, or a passive film is formed around the steel rebar. Whenever this passive film get break, or we call it as whenever the depassivation happens, corrosion starts, right? So for the depassivation to happen, we need certain conditions. One is, if the alkalinity is lost, that is a favorable condition for the depassivation to happen. So that is what is happening in the carbonation induced environment. In the carbonation reaction, the atmospheric carbon dioxide will enter into the concrete. It reacts with the calcium hydroxide, which is a cement reaction product, along with, in presence of water, forming calcium carbonate. Because the calcium hydroxide is getting converted into calcium carbonate, the pH will get reduced, or rather the alkalinity is lost. When the alkalinity is lost, we have a favorable condition for the depassivation of the steel rebar. And the carbonation induced corrosion is a general or a uniform section loss. That means uniformly you can see the corrosion happening to the steel rebar. The section loss will be uniform. The second condition is the presence of chlorides. In a chloride induced corrosion, especially happens in a marine environment or in an environment where it is subject to de-icing salt, what happens is that the chloride ions enter into the reinforced concrete system or enter into the system through the covers on concrete. It reaches the steel rebar, and when the amount of chlorides present in that surface exceeds a particular value, which we call it as critical chloride threshold, the depassivation of the passive film can happen. And this is a it's a regenerating process. If you see the reaction, it will form FeCl2 and it gets split again into Fe2 plus and Cl minus. So it's a regenerating process. So because of this regeneration process, you can see a localized corrosion, or what we call as the pitting corrosion in the chloride induced corrosion category. Or we will have a non-uniform section loss happening in the case of chloride induced corrosion, whereas it will be uniform section loss in the case of carbonation induced corrosion. Now, can anybody tell what is shown here? This is another deterioration mechanism of concrete. Can anybody tell? Can anybody tell what is shown in the figure? It's a signature cracking pattern. So no answers.
Temperature cracks?
No, it's not temperature crack. Any other guess? Hello?
Water crack,
Yes,
ma'am.
please.
Water crack.
Water crack? No?
Shrinkage crack.
It's not shrinkage. Yeah, alligator crack is because of what deterioration mechanism?
Algae.
Freezing and thawing.
No, it's not freezing and thawing. It is actually alkali aggregate reaction. So this typical map-like pattern it's a signature cracking pattern of the alkali aggregate reaction. So in the alkali aggregate reaction, if we use certain aggregates which are having, if you use aggregate which are having some reactive silica in that, like the opal, chalcedony type of minerals are present in the aggregate, it can react with the alkalis present in the cement, forming a gel-like compound, and this gel can absorb moisture from outside. Because of that, what happens is that this is expansive in nature, similar to what happens in the steel corrosion. The volume expansion happens, it can crack. So that is what is happening in the alkali aggregate reaction. Now these white patches, what does this indicate?
Efflorescence.
Yeah, efflorescence. Right, good. Or it's leaching. How do leaching happens? It's because when the water, the soft acidic water or soft water or normal water itself, if it enters into the concrete and if it comes out, it can dissolve the calcium hydroxide. And when it comes out, the calcium hydroxide, when it is coming out, it can react with the carbon dioxide, forming calcium carbonate. And this calcium carbonate is what is shown as the white patches. So this is again a type of deterioration of concrete. Now, this picture, what is this?
Seawater tap.
It's freeze and thaw attack. Freeze and thaw. That means in cold countries, the water can enter into the concrete and it can freeze, right? And the water inside the large pores will freeze. So because of that, the water from the large pores will move to the smaller ones. So what happens is that because of this movement, we'll have the dilation happens, or we'll have stresses induced on that, and it can lead to the cracking. Also, when the ice is formed, it is again a volume expansion process, and because of all these, it can deteriorate the concrete. And for the solution for this is nothing but the air entrainment concrete, where we provide space for the ice to freeze so that this pressure can be reduced. Now this one is the sulfate attack, in which the sulfate from the exterior environment enter into the concrete system. It reacts with this C3A and finally forming the ettringite at a later age. And this ettringite formation, or the delayed ettringite formation, is again a volume expansive thing which can deteriorate the matrix. Also, it can crack. So, hello. Okay. So that is yet another deterioration mechanism of concrete. And this type of crack, somebody have already answered. This is the cracking due to the shrinkage. So we'll have different types of shrinkage: drying shrinkage, plastic shrinkage, and all. So this is a typical shrinkage cracking of concrete pavement. And this indicate the pink color. So that means the phenol indicator is sprayed onto this. So this is the typical test for the carbonation, where you can see at the outer edge it is colorless, whereas the inner chunk is pink in color. So that means from here to this level, the carbon dioxide had penetrated, and this carbon dioxide had reacted with the calcium hydroxide, forming calcium carbonate. Because of the consumption of the calcium hydroxide, the alkalinity is lost, and that is why you see a colorless portion here. This here is still the calcium hydroxide is remaining, and you can see a pink color here. So I just want to show you some pictures of that. So in different ways we can categorize the deterioration of concrete as chemical deterioration, physical deterioration, and so on and so forth. Right. So this is a compilation of the different chemical deterioration of concrete, and why these things are happening. Why especially the chemical deterioration is happening. It is because we know that for the sulfate attack to happen, it needs the presence of sulfate ions, right? SO4 ions is required. Not only that, water is required. For the steel reinforcement corrosion to happen, it needs the presence of either chloride ions or carbon dioxide, along with oxygen and moisture. And for the alkali aggregate reaction to happen, it needs the presence of moisture. So that means we need the aggressive species to enter into the concrete system from the exterior environment. Yet another case is there when we provide these aggressive things inside the system. Suppose we use sea sand for construction or certain admixtures which is having a lot of chlorides in that. So in that case, the scenario is different, where the issue is happening from the concrete system itself. But I am focusing on a condition where the materials, everything is pakka, but the deterioration is happening from the outside. And for that thing, we need the presence or the movement of the aggressive species from the exterior environment to the interior of the concrete. And these movement of sulfate, carbon dioxide, chlorides, moisture, oxygen, all these are happening by following the mechanisms which we have studied in our school classes, which are called the transport mechanisms or the transfer mechanisms, in which the driving force is different. We have a series of or a list of transport mechanisms which play in concrete. For example, diffusion because of the concentration gradient, permeation because of the pressure gradient or pressure difference, sorption, the flow because of the capillary action. So all these can play crucial. And it's not a single mechanism that can happen or that play in a particular environment. It's a combination of different mechanisms which play so that the aggressive species enter into the concrete system. So we should have a clear understanding about the deterioration mechanisms as well as why these things are coming, or rather the transport mechanisms in concrete. So next challenge is the development of a suitable exposure classification system. So this is the exposure classification system which is present in the current IS 456, where it is mild, moderate, severe, very severe and extreme, which, see, we have discussed a lot of deterioration mechanisms, right? But it's not getting reflected here. It's a generalized classification system. What we need is a more specific one, and there are many proposals in front of BIS to include this. Already the European codes, the BS codes, everything have moved to a deterioration specific environmental exposure classification system, and this is a proposal in front of the IS 456 from my professor on the environmental exposure classification system, and I hope in the recent revision this will get incorporated. This or a modified version of this kind of deterioration specific environmental exposure classification system will be getting incorporated into the IS 456. So we don't have to worry much now on this aspect, but this is a challenge. Next, we should have suitable durability parameters and also test methods to assess the service life. And many of these durability issues are reflecting on the structure after few years. Like for example, say 10 years or 15 years, etc., where we call it as premature one because it might have designed for 100 years of service life. When the deterioration signs are happening at an early age of 10 years is not acceptable. But still, we have to wait for years to see the issues of concrete deterioration. We cannot wait that much time to give the payment and all. So that means there should be test methods available to, or rather we need accelerated test methods which give us a quick and reliable data at early stages itself.
Yearly coordinator and one of the second vice district governor candidate line chartered accountant Rajesh.
Hello. Hello.
Yes, ma'am, it's muted, ma'am. You can continue.
Okay. Okay. Now I thought he is asking some questions to me. That's why I stopped. Yeah. Again, and these test methods should be cost effective, and the parameters which are available or which should be derived out of these test methods should be capable to be incorporated into the service life prediction model, so that we'll get the quantification of the service life of that structure. And in this direction, the Indian Concrete Institute have constituted a technical committee on concrete durability, and I am rather the secretary of that technical committee, and we had come up with the handbook on concrete durability. And you can see these test methods and the parameters are all compiled. We put a lot of effort in compiling these test methods for each and every mechanism, or for each and every deterioration mechanisms. The relevant test methods are compiled. We don't have to create a new test method at all. It's available in Indian standards. Very few are there, but it is getting codified these days. Already the water permeability test is in place. Now the oxygen permeability test is getting codified. The surface resistivity test, the work is going on, and I'm also a part of that one. So we are drafting all these things, and it is now will come as a part of 516, IS 516, the testing, the code of practice for the testing of concrete. So until these are getting released, we will have, or we can test, or we can use the other codified test methods like the ASTM from the European standards and all. So we have made an attempt to compile all these data in the ICA handbook on concrete durability. There is a chapter on the test methods for different deterioration mechanisms. And next is very important. We need to have a quantification of these durability parameters for concrete having different supplementary cementitious materials. Why the supplementary cementitious materials are important? Because of this reason, which is displayed. So what is displayed here is the cementitious reaction, where the cement reacts with water, forming calcium hydroxide and the CSH, where CSH is the binder. And this CSCH, or the calcium hydroxide, can react with the amorphous silica present in the supplementary cementitious materials, forming more CSH. This reaction is called the pozzolanic reaction, or we call it a supplementary cementitious reaction, because the CH plus S reaction leads to the formation of more CSH, which this CSH is cementitious in nature, right? So we'll have an additional cementitious reaction happening. So that is what is called the supplementary cementitious reaction, or the pozzolanic reaction. And because of that, what happens is that more binder is there in the system. It can improve the strength as well as the durability of the concrete. Why? Because it can improve the porosity of the system, right? The pores are getting refined. It are become more tortuous in the case of the matrix having more or having supplementary cementitious materials. That means the concrete will become more stronger and less permeable when we use the supplementary cementitious materials like silica fume, fly ash, slag, etc. So this is very important that we need to have a database of this one with the supplement database of durability parameters with the supplementary cementitious materials. Next, having developed all these, we should have a good or we should develop the acceptance criteria for the durability parameters. So what do you mean by acceptance criteria? We have the acceptance criteria available for the strength, right? So we design the concrete for FCK plus 1.65 into S, whereas in the field we check whether it satisfies FCK plus 0.825 into S, right? So that condition is there in IS 456. Similarly, we should have the test methods or we should develop acceptance criteria for the durability parameters as well, so that it can take into consideration the variability between the laboratory conditions as well as the site conditions, and also these durability tests are having a lot of variability because it's not a common test, or it's not that the tests are not performed commonly. So because of that, the trained people are less available. So because of all these, we have a lot of variability happening, and in that direction also ICI had taken a lot of initiative. A round robin test had already taken place to assess the variability of different durability parameters, and this is again a challenge in front of us. So I'm not going in detail about that. Next, with all these things, the major challenge that we face is on achieving the proper durability on structure. In India, we have everybody knows concreting, right? So people used to say, what is there to research in concrete? After all, it is cement, water and aggregate mixed together. But a lot of things are there to do. That's why we are here in this platform. A lot of things are to be conveyed, or a lot of things are to be taught in this area. But this is a material, even though it's the most consumed construction material, it is treated by unskilled laborers which are not trained, and the level of mechanization is less here. And obviously, many don't know about the concrete, the science of concrete. For example, if the concrete is not workable, the people will add simply water. And the water is designed. We are doing pakka mix design. We'll take this measurement chart, take this much amount of water, do the mix design pakka in the lab, and then once it gives to the site, many times what happens is that if the workability is not sufficient, what happens is that the laborer will be the one who decides how much quantity of water to be put. So uncontrolled addition of water is one of the major issue. Curing is not given importance. If everything goes fine and if the compaction is not good, if the curing is not pakka, what happens? the quality will decrease. So I've shown here a perfect recipe for the poor quality of concrete at site. And not only that, we don't have or we have improper repair strategies. So many things add on to the durability or the deterioration of the concrete. So that means we should focus not only on the material part, we should also focus on the process part. And now, what is the way forward? We should have model guidelines and specifications for construction projects in India regarding the concrete durability. So it's good that during this lockdown period, a lot of discussions had happened, and some of the public sector as well as the public sector organizations have come up to experiment with the performance-based specification. So we are also drafting some of the model specification for some of the major construction project in India, incorporating the strength and durability. Then the exposure classes we have already discussed. We need to have deterioration specific environmental system, and we need to have a database of durability parameters with local materials so that we can arrive at the appropriate limiting values. In India, a database of such sort is lacking, and that is why we are way behind the development of service life prediction models. We can develop the model, no issues, but it need to be validated. So for that thing, we need to have proper database. That means when a particular mix is going to put in the structure, the mix parameters, many times we'll get the structural drawings, but concrete mix parameters are less available, or the data available is very few. So that is what we need, and there should be measures to ensure quality control at site. Now, for the BTECs especially, I would like to show you three or four more slides to improve the quality of concrete, and I believe that that should be the major takeaway from this lecture. So whenever you're going to be in a site, please try to follow these points. How to improve the quality of concrete? Please by heart this picture. The good quality of hardcrete will give you good strength, but it will not give you good durable concrete. So what we need is good quality of hardcrete as well as good quality of covercrete. So covercrete with low penetrability or permeability is essential to achieve durability. So this is one of the takeaway for the BTECs: good quality hardcrete as well as good quality covercrete. In order to achieve good quality covercrete, what you need? You should have proper construction practices as well. You should use supplementary cementitious materials. You should do proper mix design. You should do enough compaction. You should provide cover blocks. You should also provide good curing for this concrete. Then, controlled addition of water is essential to ensure sufficient strength and durability. So, when the water cement ratio is low, we will end up with less permeable or less porous microstructure. If the water cement ratio is more, you will end up with the more porous system, and if these pores are connected, it is a free way for the deleterious agents to enter into your system. So you should have control over addition of water. So what will happen if the workability is less? What should you do? You should use chemical admixtures. Don't increase the water cement ratio. Rather, increase or rather use good chemical admixture. Then, supplementary cementitious materials can improve both strength and durability. This we already discussed. Supplementary cementitious materials are having reactive silica, so that this supplementary reaction or the pozzolanic reaction will end up with more CSH, and because of the production of more CSH, will have more strength as well as less permeable system developed. Then this is again very, very important. Curing is very, very, very important. You know that 28 days of curing is essential in many cases, but it's not practically possible. Use at least 7 days of good curing. What is curing? Curing is you have to retain the water inside that. So even if you have a delay in providing water curing, wrap it with an impermeable membrane. So these are the small things which any practicing engineers can do. Wrap it with water and wrap it with the impervious membrane so that the water is held inside that. Start curing as early as possible. Ensure more number of days of curing. Then, when supplementary cementitious materials are used, you have to ensure more days of curing compared to the OPC. So, these are some of the tips that you should follow so that our aim is to achieve good, durable concrete systems. And this is an evidence for the increase in the compressive strength when the most curing is applied. And to conclude, I think I'm on time. It's 4 o'clock. The durability design is a real necessity. We also have seen the challenges in front of us when we think about durability based design. We have discussed in detail about all these. We need guidelines and model specifications. We also need database of durability parameters with locally available materials so that we can have our own service life prediction models. And in this direction, the ICI had taken a lot of initiatives, and one of that is the ICI Technical Committee on Concrete Durability, which was ended up in the ICI handbook. It has already given recommendations to the BIS. A lot of workshops and dissemination workshops are happening in the platform of through the platform of ICI and other ones, so that this knowledge is disseminated. And in this direction, and I acknowledge my professor, Professor Manu Santanam, Professor Getu, Professor Pillai, and Professor Matthews of IIT Madras, the BTCM division, for making me a person to present about concrete durability in front of audience like you people. And this is the research center for concrete durability at RIT Kottayam, where I have set up the most of the durability testing facilities. Yeah, Thank you all. I'll take up questions now. I think I'm on time. Yeah. Thank you. Thank you for listening. And if any questions, I am happy to answer.
Okay, thank you, ma'am. Any questions? If you have any questions, you can unmute yourself and ask. Okay, Joel, please continue the question session. Joel, can you hear me? Okay, ma'am. One question has come, ma'am. For a closed or box construction, like a column, how can we make sure that the concrete will perform to the requirements as hardcrete and covercrete are poured simultaneously?
For the question is not clear. For a
Closed or boxed construction like a column, how can we make sure that the concrete will perform to the requirement as hardcrete and covercrete are poured simultaneously?
You have to measure the durability parameter. For example, you can measure the surface resistivity, like those kind, or the some non-destructive test on concrete durability measurement of the covers on concrete and hardcrete, and also to assess the strength. We normally rely on non-destructive tests like for the structure, but it's always advisable to take a core and test it. And if we get the core, we can test it for the durability as well, so that we will take the core from outside to the inside, right? We have to avoid the rebar. Using a rebar, locate the reinforcement position and then take a core. Taking a small core will not harm any way to your structure. What you have to do is you have to replace or the concrete with good or more high strength concrete. That's not an issue these days. So you can take out the core and then test it for the strength as well as durability. No issues. But non-destructive tests are also available.
Hello, ma'am. Are you hearing?
Hi. I can hear.
Another question, ma'am. Does durability of concrete gets affected more by external or internal factors?
It depends. Normally, as I said, if you are using very bad quality concrete or very you are using sea sand for construction, before it is getting exposed to the environment itself, it will start corroding or it will show the signs of deterioration. So that is why the code had given limits on these things to be used. For example, if you see IS 456, there is a limit for chlorides, right? So that is why if you are using the specified standard materials, you don't have to worry about the corrosion or the deterioration from inside. Then the outside things are more determining one.
Okay, ma'am. Another question. If increase of curing period is more than 28 days, what about the strength and durability?
It will always be more, but you can have more, you can assess the material potential, but it's not practically feasible.
Oh, okay, ma'am. Okay. Another question. Can give an idea amount of silica plume should be added to cement?
I didn't get you.
Silica plume.
Silica fume.
Ideal amount of silica plume should be added to cement.
ideal amount of silica fume? I think it is 5 to 10%, not more than that. Yeah, it is again, it's the specific gravity is very low. It will be very bulky. So normally people used to do 5% or something. Yeah, I think so.
Okay. Another question. As we are curing for 28 days, we can reduce the curing days to 7 days. It's practically possible.
That is what is happening. The concrete is not getting cured for even for 7 days. So
Okay.
because of that, the durability parameters will get reduced. But that is why we should have the acceptance criteria.
Okay, ma'am. What will happen if water cement ratio is more in concrete? How it affects?
This is the answer for that. If the water cement ratio is more, the microstructure developed will have more porosity in that. So this, if the structure is more porous in nature, it will adversely affect the strength as well as durability. So ideally,
Okay.
we should have enough water to complete hydration. That is sufficient. So normally it is said that 0.24 water cement ratio is sufficient for the hydration. Not all water is used for the hydration.
Okay. Another question.
But we should have enough water. Why? As the
Hello. Can you hear, ma'am? Hello.
Hello, ma'am. Dhanya, ma'am. Can you hear?
or whether the answer was audible.
No, ma'am. It was not audible.
Yeah. So as the water cement ratio is high, it will end up in a system which is having more porosity. As the porosity is more, it will adversely affect the strength and durability. So in order to get more work, in order to improve the workability, you should reduce the water cement. Sorry, you should use chemical admixtures. So reduce water cement ratio as much as possible. So that is the correct point. Yeah.
Okay, another question, ma'am. Curing is essential for concrete. While monsoon season, we observe concrete are saturated and crack produced. So may know the reason.
Now I didn't get curing is.
Curing is essential for concrete. While monsoon season, we observe concrete are saturated and crack produced.
Curing during monsoon season also concrete is getting cracked. Is that so?
Yes, ma'am. Concrete are saturated and crack produced. The reason.
Might be temperature difference. Temperature differential is high. That is why difference in temperature happening will be high. That is why it is showing cracks. Not or some other reason. Might be.
Okay.
I'm not sure.
Okay. Ma'am, what are the advantages of natural fiber reinforced concrete, and what will be the change in durability of concrete?
Natural fiber reinforced concrete. See, fiber reinforced concrete
Hello, ma'am. Dhanya ma'am, are you hearing?
Dhanya ma'am, can you hear me? Hello, ma'am.
Somebody is muting me again and again. I was answering the question. Okay.
Okay, I'll check into it, ma'am.
Okay. So, have you heard my answer about the fiber reinforced one?
No, ma'am. Repeat it.
Hello? Can you hear me?
Yes, ma'am.
Yes, ma'am.
Okay. Fibers are of two types, microfibers and macrofibers. Macrofibers are added to improve the toughness parameters of concrete. So that is why you can see, or the post-crack behavior of concrete. So that is why you see the application of the macrofibers in application like the tunnel lining or the pavement and all. The microfibers are provided to reduce the shrinkage. So if you provide microfibers, you can improve the shrinkage crack resistance. In that way, it will be durable system. But microfibers addition, I don't know whether it will improve the durability properties. I don't think so.
Okay, ma'am. Another question. Is it possible to improve the durability of an existing structure?
You have existing structure, you have to do the repair and rehabilitation work. That is the only way to improve. If it is deteriorated, that is the only way.
Okay. Chemical attacks on concrete.
Chemical attack from what? On concrete? From
on
what?
concrete.
From what?
From the only question, chemical attacks on concrete. That's the question.
Bharat, can you please unmute and ask the question? Bharat, are you there? Bharat, are you there? Can you please unmute and ask and clear the question? No, ma'am, he's not there.
More questions are there, or is it done?
Yes,
no, ma'am.
Yes, more questions are there. How can we withstand the temperature difference? How can we withstand temperature difference? How can we withstand temperature difference?
How can we withstand temperature difference of what?
Concrete, I think.
It's not clear to me. Temperature difference of what?
Hafiz Muhammad, can you clear that question?
Huh?
Okay, ma'am. So for another question, is situation that we are ready for powering concrete in site also truck is ready to deliver but it is rainy, what we can do, either add retards in concrete or waste the concrete. If we waste concrete, it leads to economic loss, no?
Yeah, you have to add retarder and wait for the rain to stop. No other way. Or you have to provide some shade so that the water will not enter in your concrete area. Yeah, that is the only solution. You cannot waste it just like that. No, you have to plan it accordingly.
Okay, questions are over, ma'am.
Okay. So I hope the session was useful to most of you. many of you might have interested in concrete, and so it's high time that we need to think about concrete in a different way, not like a material which gives strength alone, or rather to design it as for the strength alone. We have to incorporate durability also into the thinking. And thank you, Vyasa Institute of Technology, the faculty, the student, and the ICI members for giving me such an opportunity. Thank you, Divya, for inviting me. I think so. I'll sign off now.
Can
Is it
you
okay,
make?
Divya?
No, ma'am. Can you make your video on, ma'am?
You want me to on the video? Yeah. Can you see me?
Okay, ma'am.
Yes. Thank you, Dhanya ma'am.
Okay. Bye bye. Bye bye.
Now I'm inviting Sajid Bhaskar sir for some few words.
Sajid sir, are you there?
Yeah, good evening. Good evening, Dr. Dhanya. Thank you
Hi,
so
sir.
much.
Hi.
Thank you so much because I think one of the busiest person in this industry in Kerala is right now Dr. Dhanya, because this week itself I think I'm hearing 4th lecture of yours.
No, this week it is second. But in the lockdown period, I had delivered many. Yeah, might be 10 or something. Yeah. Anyway, it's
Okay.
good that we are able to disseminate the knowledge.
Yeah. Okay. Thank you, Dr. Dhanya, and also thanks Vedavyasa Institute of Technology for taking such a wonderful initiative to do such 1 week workshop on structural and concrete. And I will just take a few seconds. Last 2 days also I was mentioning, but I don't know whether new participants are there or not. I will just talk about Indian Concrete Institute. Indian Concrete Institute is one of the leading professional bodies in India, catering to the professional needs of individuals and organizations involved in concrete. ICA was born in 1982, and now it has become a strong professional body having more than 13,000 enrolled members from 42 regional centers. It is also having 341 organizational members spread across the entire length and of the country. The main aim of ICA is to bridge the gap between theory and practice. In Calicut, from Malappuram to Kasaragod, and it was inaugurated 5 years ago. And to meet the objective of ICI, regional centers conduct varieties of programs like seminar, workshops, conferences, exhibitions, etc., both in national and international level. And a lot of colleges are also taking initiative to conduct a lot of workshop. And Vedavyas, I am very happy that one among our student chapter member of IC Calicut Center is taken such a wonderful initiative, and this being the 5th day, all the programs are very well coordinated and conducted. Tomorrow, actually, we are adding one more session. There will be Beam Lab session, and also we are adding one more session, and that will reinforce the talk done by Dr. Dhanya. That will be an advanced course on NDT of concrete by engineer Ravish, of senior technical manager from Ultratech Cement Limited. He will be talking about the core test, rebound, hammer test, etc. So I have just put the registration link on the chat box. People who can watch the chat box can register for the webinar, and also we'll be putting in the WhatsApp group also. So all the best for tomorrow. Thank you once again.
Okay. Firstly, I'm thanking Dhanya ma'am for this outstanding session on durability of concrete. Of course, this session was very informative and useful to all of us. Also, I'm thanking Sajid Bhaskar sir from ICI Calicut Center, who is the coordinator of this entire 1 week program, and our chairman, Dr. Arun Koro sir and Kala ma'am. Also, our honorable principal, Dr. Sangeeta ma'am. Also, I'm conveying heartful thanks to all of the participants that attend this session on behalf of Department of Civil Engineering, Vedavyasa Institute of Technology. Thank you all.
Thank you all. Bye.
Thank you, ma'am. Thank you so much. And thank you all the participants. We will meet tomorrow at 10 o'clock by the BIMS lab session. Okay.